Cool, all right, so almost a full room, so there are places here, so if you want to sit down as well. I'm gonna try to both view my presentation and show off demos, but we'll see how that goes, you never know. I'm gonna talk about how you with Salt can react to event and orchestrate based on those events. My name is Lovin. I'm from Sweden, just north from Stockholm. I like all things sysadmin, sysops, all those things. And I'm also working remotely as infrastructure team lead at Bloglovin. And I'm going to go into kind of what Bloglovin is, since that is kind of a big part of what I'm doing with Salt. And also big thing around what I'm going to present here today. So Bloglovin is a destination to actually read and discover content. So we are kind of an RSS reader, like Google Reader, but we're focusing on fashion and focusing on a market that marketers want to act against. But you can also actually read any content on Bloglovin, so you can follow the best Salt blogs there. We have a lot of traffic. And a lot of influencers connected to our network, so we can kind of connect bloggers with actually users. And we're also sending a lot of traffic from our platform and from our site back to the influencers. So they kind of like us. We're also kind of a small startup, or when I started we were 15 people, and kind of grown into around 50 people nowadays. We have bare metal servers in Stockholm, since the company kind of started there. We've moved most of the company to US, but not the server part, which I'm kind of responsible for. So at Bloglovin, we have a IO team, infrastructure operations. We're 3 people currently. We manage our servers, and we also manage everything within the infrastructure part of it. So our job is to make sure that all the developers can develop and can deploy and can push new features so that the company can survive. Well, all of those things that all of us does, basically. So we put a lot of thought and kind of energy into actually making it easy to just be a 3-man shop, into actually be able to deliver deploys and new product features every day, all the time. We started using SaltStack for about 2 years ago when I started. Before that, everything was installed manually, so it was jumping into the server, running up, get install, all of that stuff. So I've been working with that for about 2.5 years. I'm a huge fan, trying to advocate to anyone that they should use Salt, because you can do all of the things that you want to do, and which is probably the bad part as well, because you're going to get spread out. Today we're running mostly everything via Salt. So we orchestrate our new machines, we orchestrate users, we deploy, set up containers, sync databases, anything. And we put a lot of energy, as I said, into actually our deployment part, which is the things I'm going to be talking about today. But we also spin up, so when a new developer comes to Bloglovin, we spin up a new developer environment for them with everything that runs in production, but just downscaled to 1 machine. So before I get going, how many here has worked with a Reactor in Salt? Quite a few, awesome. How many has worked with the Orchestrator Runner? Nice. And how many has worked with beacons and engines? Cool, all right. Then just getting the sense on where I should focus the time and effort. So first, before actually going down and showing off events and all that fun stuff, I'm going to be talking about what I think is kind of the main reason for Salt, and how Salt should be used. Like it's very easy with Salt to just start with states and just use that. And it's very convenient to have that, then high state, and then you're done. But there is another layer underneath, which is the one that I want to kind of share with you here today. And there are kind of two things which I want to be focusing on: parallel execution and event-driven. And both of those, when I started looking at Salt, I had no idea what that was. I just wanted to run command at the same time on all my servers. And so we're kind of gonna go into deeper in both of these. Cool, so yeah, just as I said, kind of usually you start out with kind of the fundamentals, you start out with the state, and then you continue on, you do configuration management, you set up your states and your pillars and your grains and all of that. And we kind of went through that timeline at Bloglovin as well. Kind of started with remote execution, went down to writing states for everything, kind of came out where our states were a mess, basically. We had so much Jinja and so much things around each environment in the states that kind of went out of control. Cool, so let's start with parallel execution. Everybody, I think, has done the test ping command against a set of servers at the same times, which is nice and is kind of the core function of Salt, remote execution with the different modules, and which is kind of the key basics of Salt. And of course, yeah, you can use any other module, and kind of the nice thing is that you can also targeting in kind of a complex way. This is, yeah, well, the easiest targeting, you just target the name, or you target all your minions. But just having the possibility to actually target on operating system, environment, grain, all of that is for us at least a really huge advantage over other configuration management systems. And kind of, this is great and all. You can run your states or your modules or whatever against a set of servers, but usually that is not what you kind of have as the end goal of your setting up your infrastructure. A real user case scenario never goes out to actually just installing Nginx. You got to have the whole kind of stack there. So we're going to get into that in a minute. First, we're going to talk about like traditional configuration management. Like all those systems that before Salt, I used Puppet and Chef, and before that, Bash script was a big thing, at least for me. And I still love Bash scripts. Those you can do enormous amount of work with them. But kind of all the older ways of thinking about it, and how the way that I thought about it going into Salt as well, was that I had a master and I had a set of servers, and they went into the master, or the master kicked them and said, now you should get up to state. Now you should run all these modules or all these playbooks or whatever. And in the meantime, during kind of those points, anything could happen to the system. People logged in and changed stuff, and that could happen as well right now. But with Salt, you can actually do something about it. So you can actually kind of take it to the next level and actually reacting to when stuff is happening on your servers. And that is kind of the greatness, I think, with event-driven infrastructure, and kind of Salt is built up on the event bus. That's everything it is. Just something, sending an event and then returning an event. Cool. So basically what I'm gonna be showing here today is I kind of want you all to go away from this thinking that, yeah, I'm gonna go and try out something new with events today or tonight, or maybe after you have the first beer. And then I'm gonna actually show the kind of orchestrate states that we're using to deploy. They are still a bit rough in the edges, but I think that it's always fun in a presentation to see that this is how you do it, but it's also fun to see actually this is what we're running in production today. Cool, so let's start with events, kind of the basic thing. In Salt, we have the event system that actually does everything. It sets up the minion, everything that is actually happening. So kind of here is a really easy one where we do a test ping. This is how it looks when we actually print it out. And this is when we initiate the test ping. And then when we actually get the return from the minion itself. So the kind of event structure is quite easy. You have a tag, which is basically this part, and then you have all the data, and it can be as complex as needed. And all the tags, they start with salt, and then you can actually modify them against your will in a different state. We're gonna look at this soon. All right, let's see if we can do the first run here. So I'm basically just going to show you what I showed you in the presentation, but I think it's fun. It's quite fun and interesting to actually see it in real life. So here I have a master and a minion, and on the master I'm just running, looking into the event bus. So I'm just gonna, no, that's not what I'm gonna do. I'm just gonna do salt minion test ping. And wait, my love demos. It's not running at all.
Brought up the video package, so I had to manually start those.
Oh yeah, I have to do that from time to time as well. Hmm? Hmm? No, it's actually, so the name of it is Salt, but there we go, so. Whew. Thanks. But it's, yeah, I should probably restart them. Basically, I don't know, it happens actually when you run in Vagrant. Yeah, something happens with the machine and then you kind of have no idea what's going on. So I'm gonna just reload them. See if we can get that going. In the meantime, let's, when that is kind of restarting, let's go on, kind of plan that would probably happen. So another part around events is that you can actually get more events than, so when you run a state or when you run a direct execution module, you get back something. You can actually trigger so that on events, you get back an event for each part of in that state. So, and you can also specify a specific name for that event. So you can listen on to, let's say we have a state that installs something like this one. You can actually say, I want to know when this is done so that I can react to it and do other stuff. All right, so I'm just going to go through it and then we can look at it afterwards. I was hoping to actually be able to switch between so you could see it in action when going through it, but we'll just go on and then we can actually look at it once those restarted. So this one is actually quite a nice one. I didn't know it before a couple of months ago, and it's very nice. So we use it, for example, when in our deploys, when we want to fire off other things that should happen, but it's actually not part of the deploy. It's just a call that needs to happen or notifications that actually doesn't need to be in the same orchestrator. And then you can also call Salt events from any other place on your minion. So you can actually just call it from a bash script if you need to, or you can call it from anything else. Cool. So that is kind of the event, and that is kind of all we're going to work with here today. But there are a couple of other parts within the Salt ecosystem that kind of triggers around events and trigger off events more correctly. So we have beacons, which some of you have worked with. Beacons is actually just sitting on the minion, triggering off events, kind of for things that are not Salt related. So the beacon system kind of allows the minion to hook into other stuff and actually just send an event when something else happens. So in this case, we're looking at just basically this beacon does a service status and checks what it gets back. And then it actually sends that back each time on the event bus. And for the beacons that exist, isn't that many right now, I think, but in develop there are quite more than actually in stable. And this one for particular, you can do a couple of things with. You can have on change only, otherwise it will actually send back event each time, which gets messy on your event bus. And the beacon is actually running, as I said, on the minion as kind of an extra process. There is also kind of when you do these things that you listen on something and then you want to run on high state or state, you can get kind of bad things happening as you kind of want to upgrade and fix something with Nginx and you have to stop it, and then this thing will actually repeat itself and try to start it again. So there is actually an argument you can set to disable beacons during a state run. Cool. Yeah, and so the other thing, which is, I think was released during SaltConf last year, is engines. And engines are kind of the same as as beacons, but they are kind of more long-running processes. A process that looks into other processes or other things that are happening on the system or external things as well. So you can hook it up against Slack and have Slack commands being routed into the event bus. You can jack it up against queues. I think there is a one for RevDemQ, one for SQS, and etc. And kind of the cool thing with engines, we haven't really done that yet, but I would love to look into it more, is that you can actually change the event. So if an event happens, it will then be stateful, so you will remember that event, and you can do different things depending on the event within the engine. Cool, all right, so this is kind of great and awesome. We have events for everything, and you should kind of consider to add events for everything you do. You don't know when you want them, but they will be there, and Salt is kind of built up to handle a lot of events. So here comes kind of the reactor to fix everything you would have hoped. And the Salt Reactor is sitting on the minion, or no, on the master, and actually just taking in all the results from the event bus, or just listening in on it, and triggers other things depending on the tag for that event. So kind of the cool thing is that you can kind of listen to all the events and determine what to do with them. And how you do that is that you have a config file, or you put this in the master config files. Doesn't really matter. And it's basically just listen to tags. So these are the same parts as the tags in the actually event bus. So we'll listen into different things, and then it will actually trigger off a reactor worker that will take a SLS file. It's not the same as a state file. It has kind of a different structure to it, but it looks kind of the same. and then that will trigger off other things. We will look at that in a minute. You can also hook it up to, which we use a lot, to the Net API, so that you can talk to Salt's API, and it will actually trigger the reactor to then trigger other stuff. Especially good when you want to communicate with other system and have other system triggering off Salt to do things for you. Cool. So kind of the major things that the reactor can do is that it can trigger off remote execution. So basically running your CMD run or running your states or whatever. But it can also trigger off runners. We're going to look at the Orchestrator Runner in a while. And it also handles all the internal Salt stuff with the Wheeler runners. So you can actually manage keys and setting up new minions. So the basic structure in a Reactor SLS file is that you have just normal Salt things. You have the ID, and then you call the local runner in this case. And the function in this case could be CMD run. It could be service restart. And then you put in a target. Which minion should I target this against? You can use all the targeting functions that already exist in Salt. And then you can send in whatever you want to. Here's an example that we used for running a state, basically. This one we're taking in stuff from the reactor, in this case taking it from the Salt API, triggering off a sync against the targets, and then actually running a State SLS and deploying containers, with also taking in the data from the event itself. So this would actually look exactly like this one if you would run it via the command line instead. And going further, you can also run a high state like that, and also just starting the Orchestration Runner. So you could do everything within the reactor file, but it's kind of neat and nice to actually do it in the Orchestrator instead. We're going to get to that in a minute. Cool, so everything kind of leads up to the Orchestrator. The Orchestrator is a runner that has all the context as the Salt master has. So it kind of have an overview view of all your minions and all your pillar data, all your grains. You can combine all of that together and kind of work with that. And that is kind of especially good if we go back and we don't just want to run this against our web minions. We want to deploy something against the web minions, and then we want to reload a cache on other minions, and we want to kind of make sure that these MySQL migration scripts has been running before all of that. That is kind of where the Orchestrator shines, when you can do different things against different targets, and kind of renders in that way as well. Here's an example of an Orchestrator SLS file. So in the Orchestrator SLS file, you can target, you can use states underneath, or you can actually run stuff locally as well. So in this case, we're spinning up an AWS instance, and then once that is done, we're on a high state, and then we do a lot of other things as well. But I kind of took those things out. You could do this at just setting in the minion that it should actually trigger high state once it's up. But it's quite nice to actually be able to, within the Orchestrator, have all that information available and then do other things afterwards. And maybe before that as well. Maybe have something that needs to happen before the high state, which in our case we do. Cool, and I would recommend looking into using require parts, or actually just to fail hard is really useful in the orchestrator. Sometimes you want to fail hard, sometimes you just want to make sure that things happen in the right order, even though it's running from the top down nowadays. But you still want to make sure that it doesn't continue if something bad happens. All right. Cool. So we're gonna go into the orchestrator files in a minute, but I just want to go through what we do in our deploys. I was here talking last year about deploying containers, and we kind of went away from that because container deployments are too slow. We still run our infrastructure within the container and our application within the container, because Docker is awesome at actually just virtualizing the runtime in an easy way. But we actually do the building, the deploying, all the other things around outside of it, and then just mount in the code in the Docker container. So basically, in the case here, we want to build something, we do that on specific minions, and then we want to actually just get that thing over to our application servers. We do that against those servers. We also want to kind of clear out some cache, both on our internal load balancers and on our external CDNs. And then, as you're going to see, we do a lot of other things, like if it's this environment, do this with a couple of map files and different stuff. So let's jump into that one. Let's see. Where this one went. Is it big enough? Cool. So bear with me here and think of this as not perfect, but working. So this is our Orchestrator Runner for actually building. And we build both PHP application, Node.js application, Java applications. There are a lot of different stuff. But the orchestrator is the same for everything. And then we just run different states for different applications. So in this case, we set up a lot of attributes. We kind of came up with which we thought was kind of a good strategy of actually keeping the states a bit so you actually know what is what. So we do a lot of things at the beginning. We test that we actually got all the information in this case, from the Salt API, from our deployment GUI that we use. And then we use map files to actually just specify application data, environment, all that nice stuff that you need to have. And let me show you one of those map files for one of the application. It's basically saying a lot like you should use these keys, you should build on this minion, you should these are the caches that you have, this is the target servers, etc. Yeah, a lot of those things, and then doing Jinja Humba Bumbo there in the bottom that you basically don't want to do, but sometimes you're just forced to actually just get in there. In this case, we're speeding up the deploy by actually copying an old one into the new workspace, checking out the new code, checking if it's one type of application, building it against our other environments, and then do all the stuff that we need to do, npm install, composer run, all of the things that the developers want. We have to kind of take care and do it as fast as possible. So yeah, it's quite a lot of things. Happens, it's quite fast anyway, but as kind of the application grows and the application stack grows, all orchestration grows with it. Something you have to deal with. So we actually split up the build parts and the deploy parts due to the fact that both kind of keeping it separated makes it easier to just do a deploy when you need to do rollback. Maybe you just want to build stuff, put it in artifacts, and then later on you want to deploy those. But it looks quite the same, taking the same parameters, but on the deploy we sync over stuff, we symlink data, we restart, clearing cache if needed. So kind of the good things about the Orchestrator is that you can do all these things in a good order and actually doing it depending on what events that comes in. Let's see if I can show that as well. So actually running an event is basically just this command. Let's see. So it's just a salt run state orchestrate, and then we send in a lot of pillar data. That's usually how we do stuff, sending in all necessary data with pillars. Cool, let's see. Cool, so that's it. And now I'm hoping that the demo is actually working again. So let's see. Kind of what I wanted to show here was that we'll actually look at a minion that has a file that grows, and then it will actually trigger off an event when disk is starting to get full, and then we can actually automatically just remove that file or do something. And we're also going to look at the beacons and the engines, because those are pretty cool. Hold on. Let's start with the beacon. Guess not. Yeah. It's actually a good thing. Yeah, the master is going. No, I think it's just Vagrant playing a trick on me. Yeah. Yeah, it happened before this as well, so. Oh, cool. True.
This is a learning opportunity.
Yeah, exactly. All right, that's not going to work, but all right, we'll just have to make it to the end without actually showing it off. Yeah, exactly.
We'll take your word for it.
Cool, but we'll see. Maybe. You never know. Or I would... Exactly. It's a different Salt master though. But like kind of the key takeaways, even though if I couldn't actually show it, and kind of the hard things that we have had issues with, is that kind of you should start using events. That's kind of all that I want to say. Like start seeing them and kind of looking at them each day will actually make you know how to work with them. It's really easy to fetch out the data from them and to do things with them. Another thing is like everything with actually Salt is to set good namespacing and set good namespacing for your keys, so you actually know what it is and what it's doing and what you should react to it when you see it. You should also let the reactor trigger orchestrate runners or other runners instead of actually running everything within your reactor context. And we've had a lot of issues with beacons, for example. A lot in the beginning because they were very unstable, and I think in a lot of ways are still. It's kind of hard to know if they will trigger off an event each time or if they will die. The same goes with engines. They are not at a state where I would put them in production yet, because you never know if they actually just restarted because they crashed or they restarted because something else happened. Also look out for the failback loop. So if an event is triggering another event and then doing the same thing over and over again. So if you actually need to stop your Nginx, you should be able to do that. And you can do that when you run a state, for example, or when you run an orchestrator. But you have to look out for actually not triggering stuff off at the same time. And kind of the last part is just that in the orchestrate and all these parts, just iterate and iterate and iterate. There are no like shortcuts you can do, and from time to time there will be some bad genia in there. Yeah, that's it. Questions?
Will you be available later today or tomorrow for demoing that?
Yeah, definitely. So actually, I will maybe have this talk tomorrow also.
Okay.
It's not settled yet, but I'll be around here if you want to. Maybe I need some time to just get it up,
Yeah.
but I can definitely stay around and have some time showing it off, because it's cool to actually see how it works. That actually when you write the command, you first, just the test ping is actually quite nice. You actually see that the first one happens first, and then when the minion responds, it gets back. So definitely. And I'm going to be available here after the talk as well if anybody wants to talk about these kind of stuff. If anybody wants to talk about running containers, I'm also happy about that. Cool. Yes?
Did you ever have, so my position, or my thing is that I have a lot of minions who would reconfigure a service. It's about monitoring. And then the master monitoring service needs to be restarted, all the stuff is buttoned up, so you could have like 30, 50, hundreds of minions saying, oh, I wanted you master being restarted. So what I'm looking for is, how do I collect all these events from the minions that tell me that the master needs to be restarted or reloaded, and then put them all together or aggregate them and only do the restart once.
Interesting case. So the question was if you have a lot of minions that sends back events and then you want to kind of culminate those together and then just do it once. I haven't done it, but the thing that we're using a lot, because we have a lot of minions that are coming back to the master and want to do different things, is to use Q equals true as default to actually the thing that came in first will actually be the first thing that the orchestrator or the reactor will do, and then it will do the next thing and the next thing and the next thing.
I think this is what Thorium trying to solve. I'm not sure. We should look into it.
Yeah, that's the new thing, right?
Yeah.
But it's just giving it the 20 16.3, and it's very, very early, so.
Yeah, so
But
probably.
they're making it short for
Different mediums.
there's
Because I
a
was
collection of things, and then
Ah.
you can see
Up-
there's a certain level, like less or more, and then
I
make
see.
a decision.
That's
and then
that's kind of thing that the orchestrator doesn't really have today. So I would probably hook it up to something else that you have a reactor that takes in all this data, and then you save that down, and then you run an orchestrator like once something else happens.
I was trying to use the queue,
Oh yeah.
and every time one of those events come in, just recreate the queue event that is unhandled yet, and
Yeah.
contains the timestamp when it should be handled.
Ah.
And every minion that fires the event just rewrites the timestamp to another.
And that saves on the same data into the same structure.
So the restart would happen in 1 minute, but only if no more minions come in and say that they will.
Interesting.
But it didn't work.
I would probably save it off somewhere else, like in some kind of database. We're using etcd a lot, where we kind of get things in from the reactor and then save them there, and then we know what to do next time we trigger off something. Cool, thanks. Any other questions?
Did you run yourself into any reactor beacon loops?
Hmm?
And did you ever get yourself in any loop?
Yeah, we did. We had a beacon that was supposed to kill long-running processes. So we have a worker system where our PHP workers run, and if they're running longer than 5 or 10 minutes, they shouldn't. They have a kind of built-in system for actually killing themselves, but they usually don't do that. So we had a beacon that was trying to do that, and it failed miserably. So.
Lessons learned on how to catch yourself, prevent yourself, or other?
Test out the beacons. We did write our own beacon and test it out before putting it into production, like for a longer time period at least, and with kind of the same data as always. You don't have the same kind of data to test with in your staging or dev environments. That always bites you back, but it's hard. There are no like easy ways out of that. Thanks. Any other questions? Cool. I'll be available here, and should say this. Provide me feedback, and thanks.